Today we are going to discuss the topic in the combinatorics. The first topic is sum rule and the product rule. So here, what is a sum rule and what is the product rule? The sum rule here, suppose there are any two tasks are performed, T1 and T2 are any two tasks. So T1 can be performed in m different ways and T2 can be performed in n different ways. Then if these two tasks cannot be performed simultaneously, that means any one of the two tasks can be performed in m plus n ways. M plus n ways. Suppose there are two tasks will be there. T1 and T2 are two tasks. T1 is performed in n ways and T2 is performed in n ways. Then any one of these two tasks, it is not possible to perform two tasks. So two tasks cannot be performed simultaneously. Any one of the two tasks can be performed in m plus n ways. So this is known as a sum rule. In general, if there are k tasks, T1, T2 and so on, Tk, then T1 is going to be performed in n1 ways, T2 is going to be performed in n2 ways, and so on. Tk is performed in nk ways. Then any one of these k tasks can be performed in n1 plus n2 plus and so on, nk ways. n1 plus n2 plus and so on, nk ways. So any one of the tasks among so whatever the tasks are given, if the tasks are n tasks will be given or two tasks will be given, so it is going to be performed any one of the tasks in m plus n ways, or if k tasks will be there, then n1 plus n2 plus and so on, nk ways. This gives the sum rule. So for example, let us consider problems which are related to the sum rule. So how many ways? There are 16 boys and 18 girls. So there are 16 boys and 18 girls will be there, and we have to select any one of either boy or girl as a class representative. That means both it is not possible to select. Only the class representative can be either a girl or a boy. So here there are total number of boys are 16 and the total number of girls are 18. So the total number either boy or girl, then I am going to add. That means there are 16 ways I am going to select a boy. There are 18 ways that we are going to select a girl. So this is m and this is n ways. So any one task, either we have to select a boy or a girl. So any one of the two tasks can be performed in m plus n ways. This is m and of course this is n. So the class representative, either a boy or a girl, can be selected in 34 ways. So this is the way that we are going to select. Now in the same way, the another problem is in how many ways a student can choose a book from the library which is having 12 mathematics books and 10 books on which has 12 books on mathematics, 10 books on computer science. Oh, here it is 16 books are computer science and 11 books are electronics. Let us say 10 books on, I'm just taking physics. 10 books are in physics. 16 books are computer science and 11 books are electronics. So here how many tasks is there? Task 1 is selecting a mathematics book. In how many ways? There are 12 ways will be there. And task 2 is selection of a physics book. There are 10 in number. So 10 ways we can select. And the third task is selecting a computer science book. Computer science book, of course, there are 16 in number. 16 in number. And task 4 is selecting electronic books. And of course, it is having 11 books are there. So here, there are 4 tasks. There are 4 tasks will be there. T1, T2, T3, T4. So task 1 is selecting a mathematics books. Task 2 is selecting a physics book. Task 3 is selecting a computer science book. And task 4 is selecting electronic ways. So these are the N1 ways, is N2 ways, and N3 ways, and N4 ways. So now we have to select any one of the book, So if T1, T2 and so on, Tk or K tasks will be there, and each task is going to be performed in N1, N2, N3 and so on, Nk ways, then any one of the tasks can be performed in N1 plus N2 plus and so on, Nk ways. So we are going to add all the things. Subsequently, we can get 49. This is N1 ways. This is N2 ways. This is N3 ways. This is N4 ways. So just adding all the things, we are going to get 49. So student can select any one of the tasks. Any one of the tasks means any one of the book. In how many ways? So 49 ways he can select. So any one possibility will be there. So it is not possible to select all the tasks at a time. Now, the another one is, in how many ways selecting a prime number less than 10 and even number less than 10 and even number. So selecting a prime number as well as selecting a even number which is less than 10. Now, how many prime numbers are there? Less than 10, and how many even numbers are there less than 10? So we have to take any one of the tasks. Let us consider T1 is the task selecting a prime number. T1 is a task selecting a prime number. And T2 is a task. Selecting a even number. So here, now, how many ways T1 is selecting a prime number? So prime number, how many are the prime numbers are there? 1 is less than 10. 2 is one prime number. 3 is another prime number. 5 is another prime number. 7 is another prime number. Then T2 is another task which we are going to select a even number. So here 2 is even, 4 is even, 6 is even, 8 is even, less than 10. So there are 4 in number. Now, see here, this is 4 ways and this is 4 ways. Now the thing is, there is a common will be there. So the element 2 is prime as well as even. Task 1 is performed in M1 ways. Task 2 is performed in N2 ways. So we are going to take M plus N ways, but one number is common. So it is nothing but so either it is in there the prime number as well as it is there in the even number. So I am going to subtract. So there are 7 ways. So this is related to the sum rule. Now the product rule. Now the product rule is, suppose there are 2 tasks will be there, T1 and T2 are 2 tasks. So we can perform T1 as well as T2 one after the other in how many ways? So T1 is performed in N1 ways, T2 is performed in N2 ways. So the sum rule is any one of these two are going to be performed. Now the product rule is one after the other task, one after the other. So T1 after performing T1 and we are going to perform T2. So how many ways? So it is a N1 into N2 ways. N1 into N2 ways. So we are going to perform in N1 and N2 ways. So in general, there we are going to generalize this. We are going to generalize this. Suppose there are K tasks will be there. K tasks will be there. T1, T2 and so on. Tk tasks. And T1 is going to be performed in N1 ways. And T2 is going to be performed in N2 ways. And so on. Tk is performed in Nk ways. Then there are one after the other. So how many ways it is going to be performed? N1 into N2 into and so on into Nk different ways. So the sum rule is any one of the tasks is going to be performed. Here the product rule is one after the other we are going to perform. So now the problems which are related to the product rule. Suppose a person is having 3 shirts and 5 ties. So task 1 is selecting a shirt. So how many shirts is having? 3 shirts. Task 2 is selecting a tie. So here the thing is, he is going to select a shirt as well as he is going to select a tie. So selecting both tasks. So how many? This is N1 ways. This is N2 ways. So this is 15 ways. He is going to select, he is going to choose a shirt and a tie. Now, let us go for the other example. Suppose we wish to construct a sequence of 4 symbols, in which first 2 are English letters and the next 2 are single digit numbers. So, and now if no letter or no digit cannot be repeated. So how many different sequences are going to be possible? So here T1 is one task. Selecting 4 symbols in the English alphabet. And next T2 is another task selecting a single digit number. And here it is T1 is nothing but a selecting symbols from the alphabets. Now the thing is, there is no symbol is not repeated and the next digit is not repeated. So here there are how many symbols will be there? There are English alphabets are 26 and single digits if I am going to take I have to consider from 0 to 9. There are 10 in number. Now, if I am going to select 2 symbols I have to select. First symbol, in how many ways I am going to select the first symbol? I can select 26 ways. There is no restriction while selecting the first symbol. And for the second symbol, then first symbol which I selected, that will not be considered. So other than that, there are 25. So 26 into 25 are selecting 2 symbols from English alphabet. And another one is digits. So here selecting 4 bit or 4 letters we are going to construct sequence, 4 digit sequence. So which are consisting either symbols as well as single digits. Next two are here 1, 2, 3, 4. So the first 2 are symbols. The next two are the digits. So here repetitions are not allowed. So first one is 26 and the second one is that symbol we are not going to select, 25. So here single digits, how many digits are there? 10 digits are there. And now after selecting one digit, that digit will not be selected. So while selecting the second one, the possibilities are only 9 possibilities. So I am going to get these many ways we are going to select. These many ways we are going to select. Now let us go for the other one. So here we are going to consider the next example. Suppose a restaurant which is having, see here, 6 South Indian dishes. 6 South Indian dishes. A restaurant which is having 6 South Indian dishes and 4 North Indian dishes. 4 North Indian dishes. And is having 6 South Indian dishes and next 4 North Indian dishes. And now 3 hot beverages and 2 cold beverages. 3 hot beverages and hot beverages, and next another one is 2 cold beverages. Now the thing is, for the breakfast, a student wishes to buy 1 South Indian dish, 1 South Indian dish and 1 hot beverage, or 1 North Indian dish and 1 cold beverage. So first one is up to here. If I am going to consider up to here, see in how many ways. See, selecting a South Indian dish, this is the first task. T1 is selecting a South Indian dish. In how many ways? 6 ways he can select. And T2 task 2 is selecting a hot beverage. In how many? 1 hot beverage he is going to select. So there are 3 in number. So the first one is going to be performed. T1, T2, after T1 and T2. So 6 into 3 ways. Or, that means plus, here I am just applying the sum rule. Either this is going to be performed or this is going to be performed. Now, so product as well as the sum rule we are going to apply. Now, 1 North Indian dish, 1 cold beverage. And another one is, let us take T3 is selecting 1 North Indian dish. So how many are there? There are total 4 North Indian dishes are there and 1 cold beverage. So here how many cold beverages are? T4 is selecting a cold beverage. So here 2 cold beverages are there. So one after the other. So this is the selecting a North Indian dish and next 1 cold beverage. So there are 2 cold beverages will be there. So this is nothing but South Indian and 1 hot beverage. So R, the symbol is we are going to consider plus. So now we are going to get this is first one is 6 into 3 ways and next 4 into 2, 8 ways. Subsequently we can get the total possible ways are 26. So he can choose in how many ways he can choose his breakfast is 26 ways. Now let us go for the other example. So there are 20 married couple will be there in a party. Find the number of ways choosing 1 woman and 1 man, from the party such that 2 are not married each other. So we have to select, we have to choose. See here, find the number of ways of choosing 1 woman and 1 man. 1 woman and 1 man we have to select from the party such that 2 are not married each other. While we are going to select a woman or a man, they are not married each other. each other. They are not the couple. They are not the couple. So there are how many couple are attended to the marriage? There are a marriage party. It is 20 couples are there. So 20 males will be there and 20 female will be women. 20 men will be there and 20 women will be there. Now we have to select a woman or men in 20 ways. Now let us go into consider selecting a woman in how many ways? 20 ways we are going to consider. So once we are going to selecting a woman, then there will be a 20 men will be there. 20 men will be there. While I am selecting 20 women, among the 20 women, if I am selecting any one of the woman, then he is having his husband. He is having his husband. So now, other than the husband, I have to select. So 19 men I have to select. 19 men I have to select. So there I am going to select one person is going to be select. One person is going to be his husband. So there are possibility will be there. There are 20 men we can select. 20 men we can select. But among that, one is his husband, her husband. So I am not going to select her husband. So selecting a woman is 20 ways I can select. And whatever the way that I am going to select, one person I should not select because one person belonging to his husband. So that I am going to select how many ways I am going to select? Only 19 ways we can select the men. So in such a that this is going to be 380 ways. 380 ways. If the condition is not imposed, then I am going to get to 20 into 20 ways. Now, let us go for the other example. See here, a license plate of 2 English letters followed by 4 digits. So here, a license plate which is having 2 English letters followed by 4 digits. These are the digits. And these are the English alphabets. Okay, 2 English letters. And now, if repetitions are allowed, in how many of the plates have only vowels? So here, a license plate will have consisting vowels and as well as even digits, even number of digits. So now, how many here repetitions are allowed. So how many vowels? Selecting vowels. Task 1 is selecting vowels. So how many vowels are there? There are 5 vowels are there. So A, E, I, O, U. So task T1 is selecting a vowel. So how many ways I can select? 5 different ways we are going to select a vowel. Now, how many ways we are going to select even numbers? So even numbers I am going to select. There are 1, 2, 3, 4, 5 even numbers. So T2 is selecting a even number. In how many ways? 5 different ways. Here repetitions are possible. Repetitions are allowed. So first, whatever the vowel if I am going to consider, the next is also I am going to consider the same possibilities will be there. So repetition, if I am considering A, and the second English letter also A I am going to consider. If I am selecting A, E, and the selecting again, how many possibilities are there? 5 possibilities are there. So selecting the first vowel is 5 possibility way, and selecting the second is also 5 possibilities way. So here also the selecting a digits, even digits. So this is also I am going to get in the same possible ways. So there are 5 to the power of 9 ways. 5 to the power of 9 ways. Then we are going to get 15,625 ways we are going to select whenever repetitions are allowed. Suppose repetitions are not allowed. Then selecting a first vowel is 5 ways, and selecting the second vowel is 4 ways. And selecting a even integer 5 ways. And next another one is 4 different ways. And because one is already selected, another one is 3 different ways because 2 are selected. Then the another one is 2 different ways. So this is selecting a vowel if repetitions are not allowed. If this is selecting a digit, selecting a even number, selecting a even number. So if repetitions are not allowed, so these many ways, which is nothing but 5 square into 4 square into 3 into 2. These many ways we can get the possible license plates. Now, let us go for the other example. A bit is either 0 or 1. Now, a byte is nothing but consisting of 8 bits. Now the thing is, find the number of bytes that we are going to get. And the number of bytes that will begin with 11 and ending with 11. And next begin with and do not end with. And next begin with 11 or end with 11. Begin with 11 or end. So here there are, let us say, bytes are nothing but 8 bits. 3, 4, 5, 6, 7, 8. Find the number of bytes. See here, this is how many each bit is going to be filled in how many ways? Either 0 or 1. So each bit can be filled in 2 different ways. And this is also going to be filled in 2 different ways. Subsequently, this is also filled with 2 different ways. Each time we are going to get 1 byte. So here, total how many bytes I am going to get each bit we are going to fill. There are possibilities of 2 possibilities will be there. So there are 8 positions will be there. Subsequently, we can get 2 to the power of each position, each possible ways I am going to get 1 byte. So the total number of bytes are 2 to the power of 8, which is nothing but 256 bytes I am going to get. 256 bytes we are going to get. And next, the second one is the number of bytes begin with 11 and end with 11. So begin with 11, 2 are over, 3, 4, 5, 6, 7, 8 are filled. So these 2 are filled and these 2 are filled. So now how many positions will be there? 4 positions are over, then the remaining 4 positions will be there. Each and every position is going to be occupied in 2 possible ways. So how many possible ways I am going to get? It is nothing but 2 each and every gap. There are 2 possible ways will be there. So third bit I can fill with 2 possible ways. Fourth bit I can fill 2 possible ways. Fifth bit I can fill 2 possible ways. And sixth bit I can fill 2 possible ways. And each possible ways I am going to get 1 byte, which is beginning with 11 and ending with 11. So subsequently I can get 16 ways I am going to get. And here the third one, while observing the third one, so the first one is beginning with 11 and do not end with 11. So do not end with 11, and suppose if I am taking like this, beginning with 11, so how many possible ways? The remaining is 6, 1. Remaining is 6 positions will be there. So 6 positions I can fill in 2 to the power of 6 ways. 2 to the power of 6 ways. So here it is nothing but 2 square, 2 square and 2 square. So which is nothing but 4 into 4 into 4. So it is nothing but 64 ways. So if there is no restriction, so here there is ending with 1 1 also I am going to get here. Ending with 1 1 also I am going to get this. Now the question is ending with which is not with 1 1. Beginning with 1 1 and do not end with. Begin with 1 1 should be there and do not with end with 1 1. So here if I am taking begin with 1 1, ending with 1 1, how many possible ways? 16 possible ways. And here if I am not taking into this consideration, 64 bytes I am going to get, and in which there are some bytes which are ended with 1 1 also. Ended with 1 1 also. How many are there? 16 bytes. So I am going to remove those 16 bytes from this. Subsequently, we can get only beginning with 1 1 byte and do not end with. So here it is beginning with 1 1 bytes, and of course there are ending with 1 1 bytes and does not ending with 1 1 byte. Both are there here. So I am just removing 16 possible bytes from this. Subsequently, I am going to get only 48 bytes beginning with 1 1 and they are not ending with 1 1. Beginning with 1 1 and they are not ending with 1 1. So this is the third one. And now the fourth one, see here R will be there. Here there is a R will be there. See here, find the number of bytes beginning 1 1 or ending with 1 1. That means beginning 1 1 will be there or ending 1 1 will be there, but not. So 4, 5, 6, 7, 8, but not both. See here, what is that? Beginning either with 1 1 and ending either with 1 1, but not both. But that is beginning with 1 1 and ending with 1 1 should not be occur. So here, beginning with 1 1, how many are there? Already we proved this. Beginning 1 1 will be there in 2 to the power of 6 ways. 2 to the power of 6 ways. And ending with 1 1 is also 2 to the power of 6 ways. Is also 2 to the power of 6 ways. But there should not be beginning with and ending with. How many beginning with and ending with are there? So 16 possible ways. So I am going to remove that. So there are 2 to the power of 6 plus 2 to the power of 6 and minus 16. So 2 to the power of 6 is 64. 2 to the power of 6 is 64 minus 16. So this is nothing but 112. This is nothing but 112 bytes will be there. There are 112 bytes will be there beginning with 1 1 or end with 1 1. Now let us go for the other example. Now find the number of 3-digit even numbers. 3-digit even number with no repeated digits. So 3-digit numbers I have to even numbers. 3-digit even numbers. So here 1, 2, 3 should occupy all even numbers. Okay. And at the same time, repetitions are not possible. So here 3-digit even number, not all even numbers, only 3-digit even number. This is only 3-digit even number. So when we say that it should be even, then either no repeated digits will be there. Now let us say the 3-digit number is XYZ. 3-digit number is this. I am taking x into y into z. X into y into z. So now, even number, when we say that it is an even number, z is either 0 or 2 or 4 or 6 or, sorry, this is 6 or 8. So, the z may consist, z may filled with 0, 2, 4, 6, 8, any one of these numbers, then I can say that xyz is even number. xyz is a even number. So, here what is the possibility? What is the possibility will be there? So, first I am going to select z is equals to 0. Z is equals to 0. If I am selecting z is equals to 0, then x, whatever the number that I am going to select, any number I can select from 0 to 10, but repetitions are not allowed. Whatever the number that I am going to use here, that number should not be used. So here the possibility will be there, 0 to 9, 10 possibilities are there, but already I selected one number here, so that number I am not going to select here. So how many possible ways is 9 possible ways? I can select x. I can select x. So if I am selecting z is equals to 0, z is equals to 0. So then x will have 9 choices. X will have 9 choices. So if I am selecting z is equals to 0, I am having x is 9 choices. If I am selecting z is equals to 2, I am having x is 9 choices. If I am selecting 4, x will have 9 choices. Like that it will be continuing. Like that it will be continuing. And now the thing is, how many possible ways will be there? So there are, so z and x, here, z and x, if I am taking this, how many possible ways will be there? So x I am going to select 1 into 9. And now here z I am going to select, 4 choices. See here, 9 I am going to, x has 9 choices and z is, how many choices will be there? 4 choices will be there. So 4 choices I am going to select. So then x has, because x has 9 choices, z has, and next what about y? Y will have, what about y? I am going to select x is 0, then this is z is 0, and then this is 9 choices, and this is how many choices? Because this number and this number I am not going to use, so 8 choices will be there. 8 choices will be there. So first one is 9, then this is 8 choices will be there for if I am selecting z is equals to 0. Z is equals to 0. Similarly, if I am going to select 2, then this is having 9 choices, and then this is y is always having 8 choices. Y is always having 8 choices because z and x are already over. So y is going to be selecting only in other than these two. So there are how many numbers will be there? If z and x can be selecting in, z and x can selecting in 41 ways. Z and x is selecting it. This is 9 ways, and of course this is 4 and 8 possible ways. So I am going to get, this is 4 into 41. Now y can be selecting. Y can be selecting at each time. 8 possible ways. So that is nothing but 328 ways. 328 ways we can select. So here, then x is having 8 choices. So I am just taking, then it is, I cannot select x as 0 because x, if I can take it as 0, then what I am going to get, it is a 2-digit number. So here, if I am going to select only 0, I can select only 8 possible ways. So x can be other than 0. So I can select 9 possible ways. 9 possible ways I cannot select. The remaining values, if I am going to select, remaining values, I cannot select 0. I cannot select 0 because if I am selecting 0, it is only a 2-digit number. So always I am not going to select 0. So what are the different ways? I am going to select in only 8 ways. So which is Z is already only selected here, and then I cannot select 0. I cannot select the existed one. So I am going to select in 41 ways. 41 ways. This is the only way. This is the only possibility that if I am selecting Z as 0, then the number of ways X is going to be selected like this. Then this is if other than 0, Z is selected, then how many ways that X is going to be selected. This is the 41 ways. And any way, if I am going to consider, Y is going to be selected in 8 ways. So this is nothing but 328 ways that we can select. So this is the way that we are going to selecting a number of 3-digit ways. So here another one is, let us say, find the number of proper divisors of this. So if I am going to write this as a proper divisors, I am going to write like this. Then, so in general, 2 power P, 3 power Q, 5 power R, and 7 power S, in general, the divisors, I am going to write like this. So where P is 0 to 3, Q is 0 to 2, and R is 0 to 3, and S is 0 to 2. So here, what is the possible ways? P can be selected in 4 ways, Q can be selected in 3 ways, and R can be selected in 4 ways, and S can be selected in 3 ways. So here, task 1 is selecting a P1, selecting P, 4 ways. Task 2 is selecting next Q is in 3 ways. And another one is task 3, selecting R value. So it is nothing but 4 ways. And T4, selecting yes in 3 ways. So now selecting P, Q, R, S. P, Q, R, S is nothing but N1, N2, N3, N4. So we are going to get like this. So here we are going to ask only the proper divisors. One divisor is the number itself, another divisor is 1. So we are going to remove those 2. So I am taking -2. Subsequently, we are going to get 142. So these are the proper divisors of this number, 4,41,000. 4,41,000 that we are going to get. Now, so these are the problems which are related to the sum rule as well as the product rule. So here the thing is, when we are going to apply the sum rule and when we are going to apply the product rule. So based on that, we are going to extend these concepts. While we are going to go for the permutation concepts. So here in this 3-digit number. So here what we are going to get? Selecting X1 is one task and selecting Z is another task. T1 task is selecting Z, and next T2 task is selecting X. And of course third task is selecting Y. So these many ways. So this is selecting X, selecting Z, or selecting ZX, and next selection of Y are the T tasks, 3 tasks. So when we are going to see the product and next the sum rule if you are going to apply, whenever any one of the tasks is going to be possible, then the product rule is going to be used. Any one of the one after the other task is So here I am just to say selecting a P, selecting a Q, selecting R, selecting S. These are the 4 different tasks. And here also all the tasks are performed one after the other. And here also the 3-digit even number. So selecting X value, selecting Y value, selecting Z value. Selecting X value task 1, selecting Y value task 2, selecting Z value is task 3. That means task T1, T2, T3 are performed one after the other. Is nothing but the product rule. Okay. So these are the concepts of the today's class, and tomorrow, so in the next class, we are going to extend the concept of the product rule, and for getting the permutations and combinations. And the next class, we are going to discuss those concepts. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.